QSO Today, episode 273, Steve Adler VK5SFA. This episode of QSO Today is sponsored by ICOM America, makers of the finest HF, VHF, and UHF transceivers and accessories for the radio amateur, reminding you that they have just the right rig for contesters, DXers, and rag chewers. And by QRP Labs, my friend Hans Summers, G0UPL's radio kit company, makers of the popular QCX kit transceiver. My thanks to both ICOM America and QRP Labs for sponsoring this QSO Today podcast. Welcome to the QSO Today podcast. I'm Eric Guth4Z1UG, your host. My QSO today is with Steve Adler, VK5SFA, who, as a lifelong lover of radio and electronics, worked in the broadcast industry and has recently retired. While he may say that he has not worked a day in his life, he has developed a skill set and relationships that have helped him to create a 160 and 80 meter magnetic loop antenna that won him first prize in the 2018 QST antenna design competition. The process of building this antenna and its documentation, I think, is representative of VK5SFA's dedication and attention to all of his previous ham radio projects that he mentions in this QSO. VK5SFA, this is Eric, 4Z1UG. Are you there, Steve?
Indeed I am, 4Z1UG. This is VK5SFA.
Steve, thanks for joining me on the QSO Today podcast. We have the advantage, and we'll tell the listeners that I don't often do video conferencing, but you and I are looking at each other, and you can say, where are you located right now, Steve?
So I'm located about 10 kilometres from the city of Adelaide, which is the capital city of South Australia, VK5.
And of course, I'm in Efrat, Israel, and it's kind of like we're sitting across the table from each other having this conversation, and that's really cool. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, look, upon reflection, I think it all started for me at probably about the age of 6 or 7. Someone, I don't remember who, probably a relative, gave me a little crystal set. It's probably a story you've heard many times before. But I guess with me, the little crystal set I discovered worked best when you clipped the antenna lead onto the metal finger dialer of an old Bakelite telephone that was actually out in the lounge room, because if you think about it, connected to that telephone were kilometres of wire running back to the exchange. So, of course, you had lots of signal from the stations to be able to listen to. And I remember sleeping out in the lounge room with a little crystal earpiece in my ear, tuning around the AM band, just listening to these stations, thinking it was absolutely magic that something could come through the air and not require any power and allow one-way communications. I really was mesmerised at that point.
And so what happened from there? Was there anybody in the family that also shared the interest or at least pushed you on?
No, not at all. Look, my family, you'd probably say in today's parlance, were technophobes. But my parents did recognise that I had some sort of flair there. So they bought me a Tandy, or I think it was a science fair or something like that. It was a 50-in-1 electronics kit. It was a little breadboard with the components on it, little springs and wires and so on and so forth. And you could make up all sorts of things, including another crystal set of all things. But so I remember really getting into that and just starting to get a bit of a taste of how electricity works, how batteries worked. They had little cadmium cells and so on and so forth. And you could make up all sorts of interesting little electronic gadgets. So I think that was the springboard at that point. I guess as time went on, and this now becomes the radio connection, I had an uncle who used to travel the world quite extensively, and he used to visit Asia. And he brought back a couple of these little walkie-talkies. And I didn't really understand this at the time, but they were powered from one of the little square 9-volt batteries, each one, and the speaker was actually the microphone, and it had a whip antenna on the darn thing, and it actually had a tuned radio front end and a crystal lock transmitter on 27.240 in the 11 meter band. That was a marine frequency, so a real no-no in Australia. You weren't allowed to bring those in, but he did, and I remember getting a pair of these things and took them to primary school. You know, your first school, elementary school, I guess, and had a friend who was kind of interested. So we found that we could, get either side of the sports oval. I mean, they were only 10 or 15, 20 milliwatt. I mean, they were pretty low powered, and and we could communicate across the oval with these things, and that was it. That was the hooking point for me. That in actual fact, you could hold an electronic piece of equipment and talk into it and be heard some distance away. That concept was I guess the beginning of my foray into ham radio. Interestingly, at the time, the 11-metre band in Australia was actually an amateur band. And I do remember one day we were on the oval and we were communicating and having a bit of fun. And when all of a sudden this really loud voice came over both walkie-talkies advising us that we were pirates and that we needed to get off. And, of course, it was an amateur in very close proximity because our transmitter power was, as I say, in the milliwatt range and his was probably in the 100-watt range. And so we duly ceased it and got a bit frightened at that point. But radio sort of stuck with me from that point on.
Was there support for electricity and science in your primary schools at that time?
Yeah, absolutely. And it was interesting. The actual headmaster was a radio ham. He cottoned onto the fact of what we were doing and then introduced us to the hobby also via the scouting movement as well. So that's really when that introduction, the formal introduction to amateur radio took place, but still didn't take it up. As time wore on and, you go into your teens and there's girls and all sorts of other competing interests. But the CB radio craze came to Australia around about the early to mid-'70s. And like with everybody, it was illegal, by the way. You weren't allowed to own one of these things or transmit on one of these things, but people did nonetheless. And I was included in that, and remember getting a little rig and little AM rig and putting it in the car, and but really quickly realised that that really wasn't formal enough for me. There were a lot of people there who were maybe not desirable. It was a bit of a riffraff, and so I remembered all about the ham radio, and from there really coincided with myself getting an apprenticeship in electronics servicing. With a large department store chain who serviced what they sold. So, I started going to formal trade school. I'd already finished my high school, formal trade school, really understanding in depth what electronics was all about. And of course, from there, back in those days, in Australia, we had a thing called a novice license, which was your entry level. And you needed 5 words of Morse code, some basic theory, and you got the 80-metre band, the 15-metre band, and the 10-metre band available to you. And I got in 1976 I got my novice license. That call sign was Victor Kilo 3 Victor Golf Kilo, VK3 VGK. But I was so besotted with the whole hobby, just the only way forward from then on was a full call or an extra class, as you'd have in the United States. And within 3 months, I'd studied and passed for that exam and done the 14 words a minute of Morse code and everything that you needed. And from there, licensed in that same year.
Now, did you have any Elmers or mentors that helped you?
Yeah, look, I certainly did. There was a few. So back in those early days, and he's now since passed away, but his name was Max Dalton, VK3 Delta Foxtrot. So he allowed me to visit his shack and be a second operator, and he was a big HF operator, had a beautiful big tower. I think he had a TH3 antenna. No, he had a TH6 now I think about it. It was a really big antenna, and of course the sunspot cycle at the time was quite active, and there was lots of DX around. So, I used to go around there as often as I possibly could prior to me getting my licenses. So he was the one who just gave me that practical, here you go, I'm here, you can be a second operator, go your hardest. And that's really pretty much what happened. I guess the other mentor in that same era was a teacher, technical school teacher by the name of Graham Scott. He's still alive. His call sign at the time was VK3 Zulu Romeo. He's now Victor Kilo 2 Kilo Echo. He may have retired, but he ran a amateur radio course. So his course allowed you to learn the code and also the skill set as far as answering the examination questions and whatnot. But I found that a breeze because I was already in trade school and well advanced in my electronics career at that point. So it was the code, it was the regulations and so on and so forth. But he was pretty much solely responsible for cranking out a really high number of amateur radio operators back in the mid to late 70s. So you'd have to say an Elmer. Indeed. Look, I guess as my journey went on, probably four other people to talk about. And I do believe we're going to talk about antennas that I've designed and built a little later on in the interview. But look, the first one is a gentleman by the name of Lee Turner. His call sign is VK5 Kilo Lima Tango. So Lee's an associate professor here at the Adelaide Uni. He's an expert in magnetics. He's got many patents. He is, I would say, one of the doyens of magnetic loop design and construction, and incredibly generous with his knowledge and time. He, coupled with another gentleman, his name is Paul Lawson. His call sign is VK5 Sierra Lima. So I've known Paul for a very long time. He used to be the chief engineer for our national broadcaster, the Australian Broadcasting Corporation. Expert with HFMF, VHF, UHF, you name it. He is a expert at modelling antennas and provided me just enormous guidance and insight, especially in the magnetic loop process, along with other things. Another amateur, VK5 Yankee Fox Romeo, Trevor Harwood. Again, another colleague in my professional career of broadcasting, but spanned some 37 years. He's a systems integrator, just an expert with transmission, antenna design, VHF, MF, you name it. So he's a ham who likes to tinker around, but you'll never hear him on the air. He's one of them, you know. He doesn't like talking much. And probably last and most recently, another amateur by the name of Neil Abrahams, Victor Kilo 5 Kilo Alpha. So Neil's claim to fame, he was the chief engineer of Codan. Now, Codan, your listeners may know, is a very respected HF radio manufacturer. They make HF radios for all parts of the world. They're military-grade, rugged units. So he was designed and involved in that process. But his amazing expertise among many things is the design of and use of ferrites and the like in transformers and common mode chokes and the like, and helped me enormously with a couple of recent projects that we might talk about a little bit later. But again, very generous with his time, and just answered the little missing bits that would normally take you months to work out. He sorted you out in moments. So there, to answer your question, they're probably the Elmers in my life that probably mean a lot to me as far as amateur radio is concerned.
Well, you've kind of also mentioned how important that they were in terms of perhaps giving you shortcuts to education. And that's kind of one of the things I've liked to stress over these 270 episodes, that it's really hard to be an amateur radio operator by yourself. The Elmers play such an important role, even to putting a connector on the end of a piece of coax. Would you say that all of these guys who are influential in your ham radio career put you miles ahead of where you would have been had you done it on your own?
Undoubtedly. No question. Light years ahead is what I would say, and allowed me to get on to and do other great things that possibly would never have eventuated without that guidance. And look, and to that end, you also got to practice what you preach. And, I'm proud of the fact that I've helped many a young one along in their career. It's I guess the hobby is just all about communicating at the end of the day. Now, whether that be over a microphone or the lens of a camera or in person or on a field day or at a club, it doesn't matter. It's about communication. And you're right, Eric. I mean, it can't be done in isolation. It would be well, not that it can't be done in isolation. You can have your communication via the medium, but it's much better when you can share some experiences in person.
What was your first rig out of the box there in 1976?
Yeah, well, I wish it was out of the box. So the first radio transceiver that I ever owned was actually given to me by Max Dalton. It was an old KW2000A, which is a English transceiver, all vacuum tube. all valve, except for I think about 4 semiconductors. I think there were 2 germanium diodes in the balanced modulator, and I think maybe a couple of other diodes in the power supply. But apart from that, it was all tubes, as you'd say in the States. And I still have that transceiver, and it still works. You've just got to turn it on about a week in advance to allow it to settle down.
Do you turn the voltage up on the tubes gradually?
Oh, well, look, I do make a habit of trying to run it every 6 months to just make sure that you don't get too many gases.
They're not shocked into operation.
Oh yeah, you do that. But look, people say it's got a very warm, mellow sound, and it does. But yeah, that was my first radio.
What's your favorite operating mode?
Now that's a really good question. I think that for me changed over time. And it's funny, what sort of comes around, what goes around comes around, they say. Look, in the beginning, it was anything to do with HF and SSB and the like. I passed my CW to get onto the HF bands as a full call and unrestricted license, and promptly put the key in the door, but learned the code to 14 words a minute at the time. As time went on, look, satellite communications, digital communications, then ATV came into it. So these were all favourite modes, and then you got a bit sick of that favourite mode and looked for the next favourite mode. But the one that's actually hooked me back in, of all things, is Morse code, is CW. We'll talk a little later on about a recent DXpedition I was on, but I had to get my skills back into shape, and months and months of practice listening to some great computer programs got my speed back up to an acceptable sort of a limit. Probably not by all the amateur radio community's expectations, but at least I was satisfied. So had a lot of fun with it.
And now this message from ICOM America. Heard it, worked it, logged it. It's time to get the transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products for the occasional operator, rag chewer, DXer, or contester. Make the most out of contest season with one of these ICOM transceivers today. The ICOM IC7610 is the SDR every ham wants. This high-performance transceiver has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The ICOM IC7610 is a direct sampling software-defined radio, or SDR, that will change the world's definition of an SDR transceiver. The ICOM IC7610 features include RF direct sampling system, 110 dB RMDR, independent dual receivers, and dual digicell. The ICOM IC7300 changes the way that entry-level HF transceivers are designed. This high-performance, innovative HF transceiver with a compact design will far exceed your expectations. I purchased the IC7300 last fall and have fallen in love with its waterfall display, allowing me to zero in on activity and potential QSOs on the air. The ICOM IC7300 features include RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope with waterfall display, and an SD memory card slot. The ICOM IC7851 is the primo contester's HF transceiver. Keep your competitive contesting edge with faster processors, higher input gain, higher display resolution, and a cleaner signal. The ICOM's IC7851 is the pinnacle of HF perfection. The ICOM IC7851's features include dual receivers to allow you to listen and to pounce on contest contacts, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and an SD memory card slot. So be ready for the upcoming contests this season with a new ICOM transceiver. ICOM has rigs for every level of operator, and they are available at the ham radio store near you. Go to www.icomamerica.com/amateur for more information on these fine ICOM transceivers. And when you make that ICOM purchase, be sure to tell your dealer that you heard about it here on QSO Today. And now back to our QSO. And what software would you recommend then for someone that wants to bring their CW speed up?
Yeah, so look, I really ultimately ended up with Rig Runner. So it was a very targeted purpose for the CW. I just wanted to be able to receive call signs really quickly. And the mode of operation on our D expedition was to receive by ear and go back on the keyboard was the fastest way. And then, of course, you got perfect Morse as far as your sending was concerned. And you could have all the macros. The idea is you're trying to work as many people as possible. So, yeah, that's how it was done.
Trial by fire, pretty much, right?
Indeed. Indeed. And let me tell you, when you're on 160 metres of a nighttime and you've got a lightning storm 1,000 kilometres away, after about 10 hours with headphones on, your ears are bleeding, let me tell you. But it was worthwhile nonetheless.
Well, how did your career proceed after that? Because when we first started talking, you started mentioning that you were actually in broadcast radio. So what happened in broadcast radio, and where did it take you?
As I sort of mentioned, I did an apprenticeship in servicing just domestic equipment. So, colour televisions, black and white televisions, stereograms, radios, you name it. And that was just a wonderful, wonderful grounding for repairing things. It just gave you that skill set that you just learn by practice and trial and error and good mentors, good masters as you were an apprentice. But it's just, I just knew it's not where I wanted to be. I just didn't want to repair consumer goods for the rest of my entire life. I was more interested in radio communications in general. And I guess the ham radio got me into a communications company. They were just a two-way radio company. I mean, back in those days, the mobile phone was an imaginary concept. I mean, if you had a two-way radio in your car, that was a big deal. And our telecoms company was just allowing radio interconnect from the two-way radio to the public switch telephone network, and our company was getting really big into that, and that was huge because that was not allowed in Australia. We were highly, highly regulated. So I joined this company, and look, it was just marvelous. Again, a great couple of proprietors, one really technically up there. He wasn't a ham; he was just a really good communication specialist, but he took me through the ranks of VHF, UHF combining couplers into single antenna systems and the like, networking, microwave linking, all those skills that you need to be a really good communications technician. I also went back to school, did some more study as a mature adult, and got more qualifications in that area. And look, with all these things, where it led me to, this particular day, I was called out to fix a two-way radio repeater. It was a UHF repeater, split frequency repeater, at a radio station in Melbourne called Fox FM. So this was in the early to mid '80s, and FM had just been launched in Australia, and so it was taking a while to get traction. The AM radios were still the most predominant stations in the market, and so on and so forth. And anyway, the problem was minor with this two-way radio repeater that just wasn't keying or something silly. But it was a combined system, so it was truly duplex. But what was missing was the link between the receiver and the transmitter. So it was the base station or the studios out to the vehicle, and they used it for electronic news gathering, by the way, just for the journalists. So, and then it was from the car back to the studios. But the cars couldn't hear one another because there wasn't an audio link inside the base station. And so I said to the chief engineer, I said, look, just with the addition of a couple of components and a little bit of rewiring, we could, include the audio path, and then the vehicles could actually hear one another. Would that be of use to you? And he'd never thought of that before and said, actually, probably could. So I implemented it. The next moment, one of the news cars started talking, and another news car who was on the other side of the city said, hey, I can hear you. This is amazing. And, of course, then they would collaborate and collude and meet and all this sort of stuff. So it was a win-win for everybody. I guess the long and short of that is this chief engineer started to pursue me to come and join him at Fox FM as a broadcast technician. And anyway, to cut a long story short, it took a little while, a little bit of persuasiveness, but I offered to do some work experience for free just to see what it was like. And I'd have to say to you, after day two, in a very vibrant commercial radio studio environment with probably easy on the eye members of the opposite sex, I was actually hooked and thought, yep, this would be pretty good. So I joined him at Fox FM, and my career then blossomed off from there. Ultimately, my pinnacle in my broadcasting career is I was the director of technology for a company called DMG Radio, which was part of the Daily Mail and General Trust, a big British newspaper conglomerate. And we set up a brand new FM network in Australia from scratch. I, in my heyday, probably was in charge of about 60-odd engineers around the country. And we built an FM network from nothing. So that was quite amazing. And then on from that with another company called Southern Cross Stereo, who, again, they have some 87 outlets in Australia. And again, I was looked after all the engineering and the personnel in that. So, that one small stepping stone just led on to all these other amazing things. So I guess if you're looking for a history and a link, that's how amateur radio played a very important role for me to get where I am. I've only just recently retired, and I have to say I miss it. But I've made a decision just to now pursue amateur radio and maybe take that to areas that I've never have done before.
Well, you mentioned earlier, before we pushed the record button, that you've never worked a day in your life.
No, I'm very fortunate. I've never worked a day in my life. Every day's been different. Every day's been something new. Every day's been a challenge. Every day's been, satisfaction beyond my expectations. No, I'd have to say I'm one of the very, very fortunate few people that could probably say that.
The majority of the listeners of the QSO Today podcast are in the United States of America. And so we Americans, and me, former American, actually I'm still an American citizen, the United States has a history of garage and backyard innovation that probably goes back to its original founders. Does Australia share a similar history for home brewing and tinkering?
I think you find we do. Things that we've invented, things that spring to mind are the shears that shear sheep, for goodness sake. That was an Australian invention. Shearing sheep used to be a laborious task with hand shears. The mechanical clipper was, made by Australian. The clotheslines, the Hills hoist, a very famous icon in most Australian backyards. Australian invention. Look, I guess the list goes on. But look, I would suggest that the majority of Australian probably were born with a spanner in their hand, is what I'd say. We like to play with cars. We like to play with motorcycles. We like to tinker and so on and so forth. So, I'd say definitely in that ilk. Hey, we invented Wi-Fi.
There you go.
Yeah, indeed we did. The CSIRO actually invented Wi-Fi.
There's a sense in, at least from all of the interviews that I've done, that amateur radio was really foundational to engineering and electronics development in North America, to driving industry. Would you say that it's also foundational to driving electronics industry in Australia as well?
To some degree, probably in the early days. You'd find that most engineers who were working in manufacturing, because we had a really large electronics manufacturing base here in Australia, but, as time went on and tariffs were reduced and things went offshore, that all tended to disappear. But, you would find that most engineers were hams as well back in the early days. These days, very few and far between, I'd have to say.
You mentioned that on your bucket list, what you wanted to do was to go on a de-expedition. And you mentioned to me before we started that you just came back from a de-expedition. Do you want to talk about that de-expedition, what its goals were, and how those goals were attained?
Oh, absolutely. So this de-expedition was founded, the leader is an amateur, very good friend of mine here in Adelaide. His name is Grant Willis, Victor Kilo 5 Golf Romeo. So he's a avid DXer like myself and loves the HF, and he works in the cellular telephone space here in Australia. So really bright individual. But he likes to activate islands in the Pacific. Don't ask me why, but that's what he likes to do. And he's always done them on his own, solo. But this time he wanted to do something a bit bigger, and started a drive to do a de-expedition to the Kingdom of Tonga. So that's A35 is the prefix. Reasonably, I think it's in the top 70, certainly in the top 30 from European point of view. It's a very difficult path on HF. Definitely up there for Earth, Moon, Earth, as it had been never activated before. So, there were four of us who ultimately went on that de-expedition. Myself, Grant VK5GR, as I mentioned, Olgeard, Victor Kilo 5 X-Ray Delta X-Ray, and Andy Hall, Victor Kilo 5 Alpha Kilo Hotel. So those guys had already committed to going. I'd just retired, and they said, hey, do you want to come along as a fourth member? We could really use your skills. And I said, you know what? That sounds like a really cool idea. So Grant, being the very hard taskmaster that he is, set down the challenges for each team member. Now, everything went in by air and everything came out by air. So that was one of the, I guess, challenges, to make everything very lightweight, very compact. Unlike Australia, here in Australia, we're only allowed 120 watts of PY or 400 watts PEP. In Tonga, no, we're allowed a kilowatt over there. That was pretty cool. So all the antennas had to be lightweight, small, easily put together, robust, withstand wind, and of course handle a kilowatt all day. no short order. So I drew the straws to make a inverted L for 160 meters and 80 meters, so the one antenna to do both. Ultimately, it could tune from 160 right through to 6 meters, and it was based on my folded monopole design, which we might talk about a little later, which really is my inspiration. There came from the folks at Step IR. They have a thing called a crank IR, which was just a fantastic antenna. So I made a homebrew version. I must admit, ultimately, I went and bought a crank IR because it's just a better quality fabrication. So the inverted L simply consisted of a very specialized binocular impedance matching transformer, because the base impedance of inverted Ls are invariably low. And of course, that was done with some mentorship from Neil, VK5KA, that I talked about before. So he helped me with that design, and just a Series C, and then in actual fact the 80-meter radial kit from the Crank IR. So I re-engineered it and had some parts made with a lathe, and it all kind of went together in a little box. There's some pictures of it on the internet. You might put that in the show notes, perhaps, Eric, where people can find that.
Sure, absolutely.
But it worked a treat. We put it right next to the Pacific Ocean, 3 meters from the ocean, radials in the water, and I was treated with a noise floor on 160 of 0. It was no noise. It was just extraordinary. You were copying signals 5 by 0, 5 by nothing, and working them. Watching the grey line come over the United States was just amazing. And then earlier in the night, maybe into Australia or Europe or what have you. So that was pretty cool. So that was one antenna. That was my little compartment. And the other one was a 4-square array for 30 meters. And again, that was used iron oxide type toroidal transformers, and also binocular transformers to do the 180-degree phase splitting for that antenna. And again, we made them because we knew a sought-after destination for the Europeans was Tonga, and the path was straight over the North Pole. I mean, Stuttgart in Germany is 0 degrees from Tonga. So you're fighting the magnetic flux lines coming back into the Earth over the North Pole, which plays absolute havoc with HF, and that extra 6 dB and the front to back ratio to null out other interferers just paid off in spades. It was fantastic. Overall, and that was that part of it. Olgeard, he did the 40-meter 4-square. Grant and Andy did the HF hex beam, and a 6-element 7-meter long LFA for 6 meters, because we also did Earth Moon Earth from Tonga, which was really welcomed by the Earth Moon Earth community, and we got about 24 contacts. Overall, in 2 weeks, 4 people, we did about 16,000 QSOs. So we were punching above our weight, we believe. It was all just with great fun, camaraderie, humour, and being very, very tired for a lot of the time.
Let me take a quick break here to tell you about my favorite amateur radio audio podcast, the Ham Radio Workbench Podcast with George, KG6VU, and Jeremy, KF7IJZ, where they pursue topics, technology, and projects on their ham radio workbenches every 2 weeks. George and Jeremy document their projects and make circuit boards available for sale to their listeners. They have interesting guests and go in deep. Even if you're a seasoned ham radio builder or just getting started, be sure to join George and Jeremy for the Ham Radio Workbench podcast. Use the link on this week's show notes page by clicking on the image. And now back to our QSO today. How are the Tonganese in terms of accepting your operation? Were they cooperative?
Yeah, look, that's a very good question. Look, what I learned from Grant has got unbelievable organisational skills and also fantastic artistic flair, as you'll see when you have a look at his website. He's just got a gift. But, exporting equipment out of Australia and then into New Zealand, because that was our intermediary point, we had to import the goods into New Zealand. So, we're talking $30,000, $40,000 worth of amateur radio gear when you add it all up. And then that's got to go on to Tonga, where it's got to be imported. And then you've got to, at the end of it all, reverse the process. We used a system called Carne, which some people may know of. It's a system where you can export high-value commercial goods and then import them back in again without paying import duties and tariffs and taxes. So Australia and New Zealand, along with many other countries, are a signatory to Carne, but the Tongan kingdom is not. But they knew of Carne. So I remember we arrived at the airport in Nuku'alofa with cases and cases of equipment, and went up to the customs official and explained what we were trying to do. And he seemed sort of vaguely interested, but was more interested in actually looking at our radio license, to be honest. He just wanted to make sure that we were going to go on air with a valid license, which of course we had from their Department of Communications. We said, look, would you like to inspect all the equipment, completely open, upfront and honest, and in typical friendly Tonganese manner, to answer your question, Eric, he just sort of waved us through and said, go and have fun, which was just fantastic. So loaded all the gear up at the airport and headed out to the northern tip of the island, basically surrounded by seawater. We actually rented a whole resort there, because we wanted to be in control of the land. We wanted to be in control of any interferers because, remember, LED lighting, ADSL modems, switch mode power supplies, they can ruin your day. So by renting the whole resort for 2 weeks, we switched off many LED lights and many little plug packs and many little things and just had a noise floor that was second to none. Did you rent that resort in the off season? We did. It was interesting. The owner of the resort thought that we were actually conducting science experiments. So rather than go into enormous detail, we sort of said we were. And I guess the real science was the Earth, Moon, Earth. That's not easy. And she was just amazed and perplexed that we were going to bounce a signal off the moon and talk to other people around the world. So they were unbelievably accommodating and really basically let us do anything that we wanted. And we in kind just made absolutely sure that when we left, there was no trace that we'd actually even been there. So, it works two ways. But it was the way to do it. Being able to rent the whole resort allowed you to be in control of everything, and including active antennas. I mean, we had reasonable field strengths, and, you don't want people walking into a 40-metre four-square array whilst you're transmitting into it. It's probably not a good idea. Probably worse on 6 metres, to be honest, because the plume it's reasonably dangerous in the near field. So we wrote that whole area off, so not even ourselves could get near it whilst we were transmitting. What do you think the most valuable personal takeaway that you got from that experience? Oh, gosh. That you'll use through the rest of your life? Well, I've always used it. Just great preparation. I mean, these antennas that I talked about, they were tested within an inch of their life back in here in Australia. We took them out on field days. We set them up. We found problems. We improved them, made them more robust. So when we got to Tonga, we just set them up and they just worked. There were no surprises. There were no fault conditions. There were nothing. They just did exactly what we had designed them to do. So it's all in the preparation, preparation in the paperwork, preparation in the getting good advice on freight forwarding handlers and the like, preparation in taking all your personal effects. So just being really organised and having a good understanding of what you're about to try and do.
In 2018, you won the first place in the QST antenna design competition for your high-power 160-80 meter transmitting magnetic loop antenna. Why a magnetic loop antenna for this contest?
Well, first of all, that was probably the most humbling experience in my life. I do remember actually getting an email from Steve Ford, WB8IMY, congratulating me that I'd won. So let's just rewind a whole stack there. But that's the first thing I have to say. It was just an amazing experience. Why a magnetic loop? Well, look, I'd read a lot about magnetic loops. And I did touch upon before an Elmer Lee Turner VK5KLT, who is the doyen, along with others. But he worked very closely with an American. Now I'm just having troubles remembering his name. But anyway, he invented the magnetic loop concept for transmitting. They've been around for a long time for receiving. You look at old World War II footage, you'll see the aircraft and tanks and everything festooned with magnetic loops because they're small. They're small and they work really well. They're often misunderstood. You know, Eric, in this world, though, there's a saying, you don't get nothing for nothing. And that is the case with a magnetic loop. Whilst they work quite well, one downside of them is very, very narrow instantaneous bandwidth. That's one thing you've got to cope with. But once you get to terms with that, the reason why is they fit into small spaces. So like my whole amateur radio career, I get interested in one thing. I like to experiment with that one thing, you know, whether they be low Earth orbiting satellites or then, you know, HF or microwaves, millimeter wave bands, ATV, all these things I've done. And then I just find my personality trait is I tend to maybe just get a bit sick of it. So go looking for the next thing, what's new. And I'd never really worked on 160 meters before, the low band, but had enormous experience in broadcasting with AM. So what a great grounding, you know, you understand. But, you know, there's no way you're going to put up an efficient radiator in your backyard on 160. It's going to be a compromise no matter what it is. And traditionally, you'd have some sort of monopole or a dipole or an inverted V. If it's a monopole vertical, you know, you've got to have a radial system that's going to work really difficult in a quarter-acre block, you know, in suburbia, hard. So I guess that's what led me to the magnetic loop. Anyway, there was a meeting that I called between Lee, Paul Lawson, who I talked about before, and Trevor Harwood, who are all Elmers. So I invited them all out for lunch at a local hotel. They did a pretty good schnitzel and good beer. And I sat down with the three of them and I said, look, this is what I'm thinking. And my concept was instead of a single loop, which traditionally all magnetic loops are, in my mind, the question was, well, why does it have to be a single turn? It's a parallel tuned circuit. It's got a capacitor across an inductor and you resonate it and then excite that somehow. Why can't it be a solenoid? Why can't we have one or more turns? You know, because I was naive. I didn't know. Why couldn't we do that and effectively reduce its diameter? Because on 160 meters, if you're going to make anything that's even 5% efficient, you know, it's going to have a diameter of nearly 6 meters. I mean, and that's a huge structure to fabricate, to hold with some sort of insulated scaffold, to be able to rotate it. You know, it was far more palatable to me to use the same circumference but make a solenoid. And in the end of that, it ended up being two-turn on advice from Lee and Paul and Trevor, and have it 3 meters in diameter. You know, much easier to work with. And but I didn't know it had ever been done before. So anyway, we sat down for lunch. I went through it all. There was lots of beard pulling and face scratching and ear pulling and conjecture and lots of beer and red wine. And Paul Lawson, who's an expert in NEC 4. Offered to model it for me, what I was thinking about before I went to the trouble of building it. So it took him a month to get it very unusual shape. This is not a normal antenna. So pixel by pixel, he put it into the neck and came back after about a month and said, Steve, this is going to work. This will actually work. And that was it. I said, right, I'm going to build it. So I needed a summer project in my annual leave. So I ended up building this magnetic loop. And all the trials and tribulations of getting it to mechanically be correct, making the components correct so that it would handle the extremely high voltages that are present at the point where the capacitor connects to the inductor, making it out of materials that are available. I ended up using PVC irrigation tubing, about 50 millimeter in diameter. Anyway, bottom line is I made it. I got it up on a test rig. I'd followed Lee's instructions. He helped me with dimensions and so on and so forth. And I remember doing my first measurement on it, and I had a return loss of about 6 decibels. It was bloody horrible. A VSWR of 3-1 at resonance. What have I done wrong? So I remember calling Lee on the telephone, crying on his shoulder, all this hard work, and this is what I've got. And so he asked me just to start giving him some dimensions of things that I'd made. And the classic error that I'd made, I used a Faraday shielded loop as the secondary loop, the excitation loop. And anything that you read about magnetic loops, the rule of thumb is that if you've got a diameter of 5 meters, then the excitation loop should be about a fifth of that, so about a meter. But what I'd done is made an antenna that was half the size, so therefore made the excitation loop half that size. So instead of being 1 meter on diameter, it was about 600 millimeters in diameter. And of course it was coupling, but the coupling was poor. There wasn't enough surface area. So Lee suggested I just maybe rework that coupling loop and back out to about a meter in diameter. And I did that and was blessed with a return loss of about 24 dB. So we're starting to cook with gas at this point. So, look, again, being from a broadcasting background, you really want to know what your antenna's doing. Especially in broadcast, because you want to hit your service area or your coverage area, or if you've got to protect other license areas from yourself, you've got to know what the pattern's doing. So the four of us, including myself, took this whole antenna out into a park, set it all up. Paul had some fantastic test equipment, a field intensity meter, a Potomac, which we use. I'm sure a lot of listeners who worked in broadcasting know what a Potomac FIM is, and of course it'll tune 160 beautifully. And so we measured this thing in azimuth and tried to measure it in elevation, which was a dismal failure. But ultimately got a sense that this thing was actually doing what it was supposed to do and was within about a dB of what NEC predicted it would do. So, I had a functioning antenna on 160 meters, 3 meters in diameter, and not a ground radial in sight. Hey, that sounds pretty good. However, it has an instantaneous bandwidth of about 3 kilohertz at 3-1 VSWR. It's like a needle. So if you want to use signal sideband on this antenna, you've got to, on lower sideband, you've got to put the suppressed carrier on the high side of the passband and fill the passband with your audio, and it works fine. CW, not a problem. Digital mode's not a problem. It works. So then I guess the funny story out of that was, where do I mount it? This is not a small structure. And my beautiful, long-suffering XYL, who has been most sympathetic to my amateur radio career and allowing me to put up towers and antennas and all sorts of things, objected violently when I wanted to put it next to the clothesline. She was pretty unhappy about that. So at that point, it looked like it was never going to be put up. But Lee came around this particular day just to finalise a few things and noticed I had a vegetable patch sort of right down the bottom of my garden, which was slightly lower in elevation than the rest of the backyard. And he said, "Why don't you just put it there?" I said, but there's sort of rising ground all around it. And he put his arm around my shoulder and said, "Steve, an antenna that is radiating RF is a 100% improvement on an antenna that's been packed away and been put in the garage." And I took his advice, so I set it up temporarily in the vegetable patch and asked my wife if that was acceptable. She said, "I can't see it, that's just fine." And I'll be honest with you, Eric, the concrete that was holding the steel pole in place to mount the antenna on was drying within about 5 hours after that conversation.
One of my questions here was to ask you about modeling this antenna on NEC first and then how close did it really come out? And you answered that question. It sounds to me like if you know what you're doing with the modeling, that sounds to me like that's key, that the antenna actually will come out pretty close to what you model.
And it did, and it does. Look, on 160 metres, it's about 5% efficient. So you put 100 watts in, you get about 5 watts CIRP. But, of course, what it does do is it puts that power down to about 15 to 20 degrees in the VRP, into the vertical. So you're aiming it at the horizon. So I've got about 38, 39 countries confirmed now on that antenna, 160 DX. Morse code is the currency of the day. FT8 is a pretty happy hunting ground too, let me tell you. I just see that mode as a tool. But on 80 metres, so here's the other surprise package. I designed it for 160. It's about 15% of a wavelength in circumference at 160, which is about right. On 80 metres, it's approaching a quarter wave, but not a quarter wave. It's really important not to be a quarter wave, otherwise it goes into self-resonance and does awful things. But it's getting to be 85% efficient. Oh, man, my country count on 80 metres is phenomenal. I've won many competitions on 80 metres from here in Australia, and Australia's a long way away from anywhere. I've got a fantastic picture, a screen grab that I took one night using FT8 on 80 metres on the magnetic loop. And the dark side of the planet Earth is completely lit up with my signals from Asia all the way right through to the eastern United States and down to South America, and just on that one antenna, 3 metres in diameter from my backyard with 120 watts of power into it on FT8. That was pretty satisfying.
Would you recommend the magnetic loop antenna, and maybe I'm speaking more in general magnetic loop antennas, but would you recommend those for people that are living in town where there's a high density of electronic noise, maybe lots are small, maybe there's some antenna covenants that prevent people from putting up traditional antennas as the solution for those problems?
No, look, that's a great question. The answer is yes. Let me explain why. So there's a couple of points you raised. So one of the things about a magnetic loop, and so we found, especially when you turn one into a solenoid, it compresses the magnetic field. And so the near field, this is the area before, so it's all magnetic in the near field. So the E field doesn't actually form until way out from the antenna. And we measured that to be about 500 metres from the antenna on 160. So, of course, the antenna and let's go back a step. Most man-made noise is electrical. It's not magnetic. So the antenna doesn't respond to it. So they're quiet. They're very, very narrow bandwidth. So you don't have all that wide noise power to deal with. So they are a really quiet antenna with regards to reception. So very good reasons to have one in suburbia. Two, they're compact. They're quite small. You can camouflage them so they just about disappear, and they work on any band. I mean, I've got the one for 160. I've got one for I built one for 60, 40, 30 because you get an octave out of the double terms. They work over from 40 meters to 20 meters or 60 meters to 30 meters. But just for fun, I built a little one for the 6 meter band, and that thing's only 200 millimeters in diameter, and it throws off a 6 meter wave, and it does it really well. So the whole thing's scalable. So would I recommend one? Absolutely. Look, since I won the competition and my article was published in QST in April of last year, there's been about 35 of these loops constructed. And I know that because all the constructors were ringing me with questions and so on and so forth, and many of them in places where there were restrictions on antennas. Matter of fact, nearly the majority. I think if you've got space, you just put up a really big monopole and a good ground system and call it done. But and look, everybody after they built the antenna, after following my instructions, explicitly said that it behaved exactly as I described. So that was wonderful to be able to offer a design that was completely repeatable in performance without exception.
And I have to point out that your documentation of the project is beyond excellent. You've got all of the test readings. I am interested, though, Steve, in how are you controlling the capacitor? You've got an electric motor. Are you using any sophisticated electronics to measure SWR, or are you just kind of tuning the motor up and down until you peak the noise and dip the SWR?
Oh, yeah, so the answer is yes and yes. So the big one, and I've never retrofitted it yet, mainly because I just deal with it. So it just uses a simple DC motor with a gearbox on the front of it, and it turns at 10 revolutions per minute. Now, that's still too coarse to be able to tune that needle-like resonance point. So I coupled that up to a little pulse width modulated DC power supply. So it'll still give you lots of torque, but you can take the voltage way down, so the motor will, I'm estimating maybe maybe 1 to 2 RPM, something like that. So that's how I control the big 160-81 to this day. The 60-40-30, I worked, one of the engineers who worked with me in the broadcast game was a fantastic software developer. And I was telling him about my, project, and he offered to help me write some software to control it using software. And so we came up with version 1, which was written in Python under Linux. It used hamlib, which some listeners may know about. It's a whole suite of different radios on their serial communication. So basically, we got the serial communication out of the radio to find out the frequency information. We manipulated that in such a way to drive a stepper motor. It was a one-way system, so there was no feedback at all. We just used points that you'd put in. So if you want to do the 40-meter band, you take 10 points along the band at different frequencies and enter into a lookup table how many steps it would take to get to that point. And then filtered that through a mathematical interpolation called a cubic spline, which a mathematician put on the internet, compiled, ready to bring straight in, and we use that. So its ability to join the dots, if you like, so smooth that line. And look, it worked really, really well on 40 meters because the bandwidth of the antenna at 40 meters was about 10 to 12 kilohertz wide. Where it fell down, I tried to get it to go on 160, but what bit me, because it was a one-way system, was temperature variations would alter the tuning from morning to night. That's how critical the tuning is on a great big magnetic loop. And so that went by the wayside. Incidentally, I have a couple of nephews who I introduced to the hobby, and they're both licensed amateurs. And both of them are fantastic software writers and also very good microcontroller software implementers as well. So we're looking at the Mark II version, which is going to have feedbacks where we actually detect the VSWR minima to correct any discrepancies. So I have got a video of it on YouTube somewhere. If you look up my call sign and my name, there is a video of the Mark I and actually working.
So we'll take a look at your YouTube channel as well. Let me ask one more thing here, and that is, for these two versions and the software, will you have a GitHub site or someplace like that where you're going to share that?
Yeah, look, ultimately, when it works perfectly, look, I found in the past with one other project, you'll develop something and it's not right, it's not right, and you give it to someone with no warranty expressed or implied, and then suddenly you're on the hook to make it right, and they tend to badger you a bit because it, So I just made a conscious decision, until it works 100% perfectly, I'm not going to put it out in the wild, but the aim is to ultimately do exactly what you said, just say, hey, come and get it.
If you put it on GitHub, though, you might actually have a whole bunch of people that'll say, hey, let me fine-tune your code for you, or add some pieces to it, become a community project.
Look, indeed. Look, I probably just had a negative experience doing that. So I'd just rather, in this instance, I'm just developing it with my nephews. It's a real family thing, and then we'll just release it. And look, then if people have got suggestions, by all means, but we just want to get it right. It's so easy to get wrong, Eric, and if it doesn't work, you could even potentially harm your transmitter, and we don't want.
I want to point out that the article that you wrote about your magnetic loop is so foundational in terms of the science and everything that's there that I think that anybody can build a foundation magnetic loop antenna and then use whatever kind of controller that they want to use in order to make that whole thing work.
Yeah, so the simplest is just a DC motor and a pulse width modulated DC power supply. Works perfectly. No problem.
What's the current rig?
My current radio, so I have recently acquired a Flex Radio 6600. I used to have an ICOM 7700 for many, many years, but someone wanted to buy that radio, mainly because they just don't build them like they used to, he told me. So I've always been thinking about dabbling in a SDR, and I would have to say this is probably one of the most, well, it is the most advanced amateur radio I've ever come across. As long as you're comfortable that there are no knobs, so I've got the version without any front panel on it. It's just a box. You're
not using the Maestro?
No. I've just got a good Windows PC here and nice big. I've got 4 monitors here in my shack. So you just run Smart SDR up, and it's just extraordinary. I have to say, I'm learning something brand new every day. It's just fantastic.
Are you using that with an amplifier, or are you running barefoot?
Yes, so I have at the moment an ACOM 1000. Here in Australia, we're only allowed 400 watts PEP, so it's only used for sideband. But that radio is going to be sold or relegated to another use, and I'm going to buy a SPE, the Italian ones, the broadband ones, because it integrates so beautifully with the Flex. I guess that's the other part that interests me, is to be able to operate this whole radio station by remote control, and they've certainly got that down pat. That's all coupled into a 3-element step IR, so the way I see it, ultimately, it'll all be completely integrated and it'll all talk to one another, and you just come into the system on your iPhone and work the world, no matter where you are.
And now this message from QRP Labs. QRP Labs has shipped thousands of QCX QRP transceivers kits to date. The odds of working another QCX user gets better every day. If you're looking for a satisfying kit experience where you end up with an amazing performing QRP transceiver for under $50, let me say that again, for under $50, then you owe it to yourself to go to QRP Labs. We have many home brewers who listen to the QSO Today podcast. For you, QRP Labs also has parts, filters, enclosures, and other handy devices to make your home brewing experience even better. You can use these parts to either enhance your QRP Labs kits or to beef up your own homebrew designs. Be sure to browse Hand's entire website. Use the link on this week's show notes page or the one in the sponsored section of the QSO Today website to get to QRP Labs to buy your QCX or any of the other fine QRP Labs kits or parts. QRP Labs is my go-to ham radio kit company. It should be yours too. QRP Labs. And now back to our QSO Today. Anybody looking at your QRZ site and your website, you have dozens of antennas on your house. Are those remnants of previous interests and projects, or do you still use all of those antennas?
Yeah, look, that's a correct question. So, no, look, the VHF and UHF and SHF ones are still there. We have VHF, UHF field days still, so I still use them on that. I like 6 meters a lot, although we're a long way from anywhere, so very difficult to get really long distance contacts, but you can get them, especially when the solar cycle's getting more toward a maxima. There is an antenna up there. It's an ATV antenna that I designed on 23 centimeters that gives a cardioid pattern. Where I live, I'm very fortunate. We're about 250 metres above sea level here at my QDH. So back in the days of ATV experimentation, I had many viewers across the Adelaide Plains, and they would send their signals to me on 2.4 and 5.8 and 10 gigs, and I would multiplex them all together, and we'd look like the Brady Bunch, and I'd send them all out on either 23 centimetres or 10 gigs. So probably they're not used all that much anymore. Look, there's a 6 metre vertical that we have just a net channel, if you like, on AM. People use 6 meters on AM. That works really well. Trying to think what else is up there. There's just a diamond tri-band 270 and 23 centimeter antenna. But gives marvellous coverage. I've got a few, they're not up at the moment, antennas that are designed for the low Earth orbiting satellites. One's a beautiful helix on 70 centimetres, so it's a mechanically derived circular antenna, and that works superbly well, even terrestrially. If you've got any tropospheric ducting, you don't see the fade so much because, of course, it listens in both polarizations. So, I've got a Lindenblad somewhere. You sort of build them and you go, well, that worked really well. Now, okay, what's the next thing?
Do you have any repeaters running at your QTH?
Look, I used to. This place is actually licensed for a DMR repeater, but we moved it to a better location, and that serves Adelaide. So that's the Motorola DMARC network. Yeah, beautiful coverage from up here. Yep, no problem.
You touched on it for a second, and I just want to come back to it. What kind of impact has amateur radio had on your family life?
Yeah, so look, as I said, my beautiful XYL is very accommodating. It was interesting. It allows me to enjoy my hobby from home, which is a good thing. But it still can be a bit isolating if you get a bit absorbed in what you do. You've got to be very careful there. You need a good balance, I think. And I try to do that. Sometimes it's a bit difficult when there's some rare DX that you're after. I'm nearly up to country 300, and those last 40 are pretty hard. So she does tell me she does get a little annoyed when my alarm goes off that somewhere that I want is on, and I have to come down and see if I can hear it. So that's maybe a little detrimental. My family take great delight in calling me the nerd of the household, and I do wear that on my sleeve. But do remind them when they're having internet problems that I'm usually their best resource, and they agree. So that's good. So look, I guess trying to keep that balance. If you don't, that can affect your home life, I'd suggest. What
do you think is the greatest challenge facing amateur radio now?
Yeah, look, that's a really good question. Look, I think pressure for our unbelievably precious spectrum from competing interests. So all your telcos and whatnot. Look what happened with the French not that long ago. I mean, they wanted a portion of the 2 metre band for aeronautical work, for goodness sake. I mean, that was just a bit silly in my opinion. And luckily that was knocked down. But that pressure is always there. So if we're not on the air and when we're not using it, there's an old saying, use it or lose it. So I think that's an enormous pressure that we have to be very mindful of. That spectrum is valuable. Everybody knows that. I think, I don't know about the rest of the world, but here in Australia, the amateur radio service has more frequency spectrum allocation than any other service except for our defence, I think, to put it into perspective. So that's a real privilege. On the other hand, the amateur service is a service that, if everything else fails, I mean, we can still get communications networks up and running pretty quickly that would be meaningful to the authorities, So I think we're valuable from that point of view, and I think our regulator and regulators around the world understand that. Man-made noise is another real threat. Over the last 20 years, I'd suggest the noise floor has increased by, I'd say 20 dB. Switch mode power supplies, voltaic rooftop solar arrays. It's shocking if they're the cheap imported ones that we tend to get sometimes. I think that's an absolute threat, and our governments and regulators really do need to try and stop these, not type approved, cheap and cheerful systems coming into our countries and polluting the HF and VHF and UHF spectrums.
Steve, could we do a better job educating our regulators in terms of what those threats really are and what that threat really means to the way things operate?
Yeah, I do. This is a really pertinent story, Eric, and it involves an interference that I had to deal with just in the last 2 weeks. Okay, so you asked me the question, can we do a better job? So, and it's slightly long-winded, but you'll totally get where I'm coming from in the end. I had an issue back in about late July. All of a sudden, I had wideband interference from about 1.8 right through to 54 megahertz and beyond. And it was receiving at my antenna terminals at neg 50 dBm, which is just ridiculously strong, completely wiping out my HF. So like with anything, there's a good method to finding interference. And the step one is to just log the times that it comes and goes. that's one of the best ways to kind of get an inkling of what on the dickens it is. So I started a log of when it would come on and off, and in the same vein started to try and direction find it using a little tiny magnetic loop antenna that I have for that very purpose. And it quickly became apparent that it was coming on towards dusk. It would go off at about 10, 11 at night, and it was at a bearing of about 240 degrees from my place. I'd use the Yagi, the step IR, to get that bearing to start with. And it quickly became apparent it was a house about 400 metres away, and it was their LED ceiling downlights being turned on and off. Right? The noise was just horrendous. I'll share a picture. You can cut this bit out, but I'll share a picture with you what it looked like. Horrible. Anyway, so I direction found it, and of course, then the next step is to work out what are your rights and obligations under our Radio Communications Act. And so I rang our regulator, the Australian Communications and Media Authority, and in Australia, we as amateur radio operators have to be qualified, and then we're issued with what's called an apparatus license. Now, an apparatus license is an instrument that has all sorts of legislation tied to it, and part of that is being able to run a communication service free from interference. Well, that's a good place to start. So the regulator made it pretty clear to me that I do have some rights, but much rather that I would, if I could try to resolve this on my own before involving them, because they also have a scarce resource. I mean, there's another problem. All the regulators are shrinking because of budgetary cuts and monetary issues and so on and so forth. So I was very happy to try and resolve it myself. Look, I basically on a Sunday morning, about mid-morning, 10, 11 o'clock, went and knocked on this person's door, introduced myself. He looked at me like I was from another planet, explained what was going on. He did admit that he had just installed 64 of these downlights, 64, right? And I said to him, look, you may not be aware of this, but, they are creating radio interference. And there's a couple of things there. In my experience, when things start emitting radio interference, sometimes they're actually getting hot, and that maybe he had bought them from an online seller and they were quite cheap. And he did admit to that fact. He said, yep, I got them from an online seller and they were incredibly cheap. And I said, look, you've done nothing wrong at all. It's actually our government that's probably done something wrong in allowing these cheap, non-compliant imported lights to come into the country. And at any rate, I asked him if we could conduct a quick test, being able to turn them on and off. He refused to do that and wanted to understand more about his rights and obligations and mine. So I just pointed him in the way of our regulator and also our Wireless Institute of Australia, which explains amateur radio in layman's terms. I thought that was a good resource to give him. He was a very well-educated person, so I just let him loose and let him do his own self-education without putting any undue pressure on him. So that was a Sunday. On the Monday morning, he gave me, and by the way, we exchanged phone numbers. He sent me a text wanting to know my license number and my call sign, which I duly gave him. So he'd obviously talked to the regulator at that point, I could tell. So I gave him a couple of weeks, made contact again, and I'd have to say he was a little more receptive at this point, probably understood the problem a little more, and was willing to do a test with me. So we did a blind test. I went home, got in front of my Flex radio. I got him on the phone. I said, don't tell me when you're turning them on and off. I'll tell you when they're on and off. And, of course, everything correlated and he could see that that was an issue. So at that point, I said, look, would it be possible... Sorry, he said to me, look, I've already had a few of them fail, surprise, surprise, and had replaced them with a compliant light that he bought from a local hardware chain here in Australia. And I asked him for the make and model number and would it be possible to get one of the interfering lights so that I could actually put them on the bench with test equipment and look at them side by side. And he was agreeable to that. So I went and bought a couple of these type approved ones that he bought, gave him one to fill the hole in his ceiling, and he gave me one of the interfering ones. So I put them on the bench, spectrum analyzer, receiver. I'll send you a video, but horrendous is all I can tell you. And that's just one of them. try 64 of them. And, of course, they were all launching the radio waves off the mains wiring in the house. It was just a giant antenna with 64 lights attached to it.
It wasn't a dimmer. They were the lights themselves that were causing this problem.
Indeed. So what happens is sometimes manufacturers will make an appliance and they will put all the electronics in them to make them work and to put RF suppression and so on and so forth. And then what they do is they start taking components out to see where it stops working, and that act of taking the components out start to make the end product a little bit cheaper. Now, it might only be 10 or 20 cents, but when you're selling millions of them, that amounts to a lot of money. And that's what happened in this case. I opened up the little electronic transformer, and look, the silk screening was on the printed circuit board. There were the 3 resistors, 2 capacitors, and 1 inductor that were labelled and missing. Never soldered in. Now, if you would add those, I would be convinced the interference would have gone away. But I've left them alone because ultimately I'd like to show our regulator what can happen. And that's for a little further down the track. So ultimately, the good news story is I demonstrated this to him. I suggested that I would go halves in the remedy. I would pay half the cost to replace all the lights. That was about a $400 exercise from my behalf. So it was about $800 worth of lights. Completely solved the problem. Gone. Just completely quiet. I've got my HF spectrum back, which is just fantastic. But, and here's the thing that I was alluding to before. He was running a VDSL internet service from home. Now, VDSL, like ADSL, uses the HF spectrum to run COFDM, multiple carriers, low information. And I asked him, I said, so tell me, at night time, is your internet performance woeful? He said, yeah, but that's just Netflix o'clock. And I said, I don't think it's Netflix o'clock. I think your lights were interfering with your VDSL service, and I'd be really interested to know how it performs once we replace all the lights. And as predicted, his internet works beautifully now at night time. So
he's your new best friend, huh?
Well, you know what? How many other people around the world are experiencing that? And what a tool, what an arrow in our amateur radio quiver, if I could use such a term, where we could help people with yes, they're interfering with you, but they're actually interfering with themselves and they don't even know it.
Great story, Steve. I really appreciate it.
So another issue facing amateur radio is, I think, our declining numbers. I think attrition is far outstripping newcomers into it. So new blood, or lack thereof, I think is a big thing that's facing us, and that's in our own hands. Promoting the hobby, radio clubs, ELMers, all the things that we talked about. Bringing STEM into schools, science, technology, engineering and mathematics would go a long way and augurs really well with amateur radio. And we're introducing that into our schools here in Australia, where we have a lack of engineers at the moment, and the government understands that. So that would also go a long way to allowing people to self-educate themselves. I mean, that's what amateur radio is all about.
Is the Australian government and the National Club of Australia, are they being successful? Are you bringing in young blood?
Yeah, look, I think we are. We certainly have a class license called a foundation license. That's very, very little technical skills, very little required. You're only allowed 10 watts. I think you get 80, 15, 10, 2 and 70 centimetres. But it gets them on the air, and it gets them talking to other amateurs. And, if they're so inclined, they'll improve and get their skills up and go onto a standard license. And then from there, go on to a full license. So it's that little stepping stone. So definitely. We have dedicated amateurs who run around to schools introducing amateur radio to the hobby and getting interest that way. So they run around. I think they've got a little van or something equipped with some demonstrations and so on and so forth. Radio fox hunting. That's another big one. That the kids love that. You give them a Yagi and tell them to go find a fox. They reckon it's fantastic fun, So just spurns their interest a little bit. So they were a couple more things that I think that we do need to, if not address.
What excites you the most about what's happening in amateur radio now?
I think the foray into digital modes. We have FT8, JT65. Look, we have had RTTY. I mean, that's a digital mode. Morse code's a digital mode. BPSK. But these, digital modes that work into incredibly low signal-to-noise or negative signal-to-noise ratios, I think are exciting. I think digital techniques coming into amateur radio, I think is fascinating. The flex radio that we touched on before is just a perfect example of that. How to do analog things in a digital way with tremendous improvements excites me. I wonder where it'll all go. Again, we have these spectral parks or sanctuaries to allow us to experiment with digital modes and RF and combine them all together. Where will we be in 5 years' time? I don't know. That's exciting.
What advice would you give to newer returning hams, Steve, to the hobby?
Very simple. Join a radio club. Join a radio club that's really progressive, that likes to do things that are welcoming, inclusive, because you'll instantly be attached to people that, number one, have probably got a lot more experience, two, very willing to share that experience and do it in a wonderful club atmosphere. That would be my strong advice. Don't do it in isolation. Join a really good radio club.
Steve, I want to thank you so much for joining me on the QSO Today podcast. It's been a real gas. I am looking forward to coming to Australia and, of course, coming to visit you at your QTH. I really like the real ham radio attitude that comes through in this conversation. So with that, I want to thank you so much and wish you 73.
Likewise, it's been a pleasure, and 73 to you too.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Steve. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in VK5SFA in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support for these fine sponsors by clicking on their links in the show notes pages or by using QSO Today in the coupon box at the checkout. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor, monthly or annually, by clicking on the sponsor buttons on the show notes page, or use my Amazon link before shopping at Amazon. Amazon gives me a small commission on your purchases while at the same time protecting your privacy. I'm grateful for any way that you show appreciation and support. It makes a big difference as I head towards episode 300. QSO Today is now available at iHeartRadio and a bunch of other online audio services, including the iTunes Store. Look on the right side of the show notes pages for a listing of these services. You can use Amazon Echo and say, "Alicia, play the QSO Today podcast from TuneIn." Special thanks to Ben Bresky, who now edits the audio for this QSO Today podcast from the audio pieces that I give him. Until next time, this is Eric 4Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.